All right, so now that we know the basics of arrays, let's start applying them in a few more practical applications and purposes to actually use them effectively, at least hopefully. That's generally speaking the goal here. So the first thing that we may want to realize is that when we're working with arrays, we don't always know the size of the array that we're working with. You're like, but what do you mean we don't know? We have to set it when we define it. That's true. But remember that we have the ability to delay that option. We can define it first and then instantiate its size later on. And maybe we don't know that size because maybe we're getting it from the user. Maybe we're getting it from some form of calculation or something like that. We don't know. So there may be times where we simply don't know the length or the size of our array. So what options do we have available to us? Well, that depends on the scenario. First of all, if you know the array is going to be full at all times, maybe you know, for example, you have a list of the top 10 high scores, and there's always 10 scores. Even if they're always zero, that may be the case. Maybe you have an array of cards. You know there's always 52 cards in a deck, so that might be always full at all times. So if that's the case, what we're going to use is there's a built-in property for all arrays called length. And we can access the length of an array by calling that property on the array's name. So something like array name.length. So for example, if I had an array called student marks, I could just say student marks.length, and that's going to tell me the quantity, the total number of elements. Now be careful, that has nothing to do with the index values. It's the total number of elements within the collection itself, okay? And as we know, our range of index values is always 0 to that length minus 1. This is where that length comes from. So 0 to the length minus 1. Now, the second option to deal with is the fact that sometimes we're in situations where our array is not full. And that can cause some complications. So our array may not be full for a lot of reasons. Maybe, for example, it was like that restaurant. We were filling up the array as we went along. Sometimes it was full, sometimes it wasn't full. Maybe you are creating an array to hold all the marks for students in your class, and your student class capacity might be like 30 students, okay? But there's only 25 students in the class. So your array is size 30, but you're only actually using 25 of the elements at any given time. Imagine trying to then calculate the class average. Well, you don't want to divide by the length in that case because that would be dividing by 30 and that would give you a wrong result. You need to divide by exactly how many students there are actually there. So how do we handle that? Well, it's common sense. It's probably exactly what you're thinking of right now. Track it. Create an integer. And every time you add a new value to your array, add 1. If you remove a value from your array, subtract 1. And that way you're always tracking exactly how many elements are in use at that moment. So knowing the number of elements and knowing the size or the length of your array is going to be a very important part going forward. Now, what about when we want to, say, for example, retrieve multiple elements in a single expression? Do we always only have to get one at a time? If you remember the example from the last lesson where I was displaying all the elements of the high scoreboard, I accessed them one at a time. So 5 different system.out.println statements to display them. Could I combine them? Of course you can. Wherever you could access a regular variable, you can do the exact same thing you can with an array. So look at this situation here. I've created an array called nums, int square bracket nums equals new int, and I didn't specify the size inside the square brackets because I'm manually setting the values right now. 3, 7, -2, 4, 0. So with that tells me that I have a length of 5. Okay, now let's say I want to calculate the average number in there. So the first thing I need to do is I need to calculate the sum of the numbers. So there is me accessing all 5 elements. Int sum equals nums0 plus nums1 plus nums2 plus nums3 plus nums4. That's going to add them all up. We see that's 3 plus 7 is 10, minus 2 is 8, plus 4 is 12. Great. Now to calculate the average, I need to divide by the number of elements I have. Now I could just divide by 5, but this is a full array, and that's a magic number. We don't like magic numbers. So we're going to divide by nums.length. So there's no numbers involved. So if I ever decide to redefine that array to have 25 elements, well, that sum divided by nums.length would still work. I wouldn't have to change a single bit of that line of code. So finally, we have our average, and now we just need to display it. So in this case, system.out.println, sums, sum, plus average, average. And we get our sum of 12, which we said. And when we divide that by 5, 12 divided by 5, well, that should obviously be a little bit different number. So it's not going to be exactly 2, right? Because we know 12 divided by 6 is 2. But because it's an integer and we can't handle the decimal places, the decimal places just get truncated. So it actually goes down to an even 2 because we're dealing with straight integers here. So this is me retrieving multiple elements in a single expression. Great. What else can we do? The next one is a more interesting concept. Something called parallel arrays. Parallel arrays are an interesting concept. So parallel arrays are multiple arrays that are related by purpose. So imagine that you want to keep track of a high scoreboard again, okay? So you're keeping track of maybe the top 5 high scores, but when is the last time you played a game that didn't also display whose scores those were? So you might have a name and a score, but we can't keep those together in the same array because one's a string and one's an int. So we can't do that. So what we have to do is we actually have to maintain 2 separate arrays. Now, we call these parallel arrays because what that means is that when you line them up beside each other, the index values that are for associated data is perfectly aligned. What I mean by that is index 0 in both arrays is for the same person. It's their score and it's their name. Index 1 is for that person's score and that person's name. So let's look at an example. So imagine I want to display an array of 5 scores and their associated player names. So the first thing I'm going to do is I'm going to define an array of high scores, just like we did before. So you can see this is what it's going to look like. We created our array, and it's got the 5 values, 1,900, 800, 700, 600. And we see the indices listed below, 0, 1, 2, 3, 4. Now I'm going to create an array of high names. Now this is a string. We got Jack, Judy, Jagmeet, Jade, and Jorge. Now look at how these are lined up. I lined them up perfectly like this so you could see that index 0 applies for both. So Jack's score is 1,000. Judy's score is 900. Jagmeet's score is 800. Jade's is 700. And Jorge is 600. So what I've created is parallel arrays, like parallel lines. They never intersect. They always work together. Okay? Now, what am I going to do with those? Well, I want to display the values. So for each one of these, you can see that for writing out first place score, I'm writing out high names at 0 and then high scores at 0. And then I'm going to do the exact same thing for the next 4 elements. And we end up with a nicely formatted high scoreboard. Now, could we make that formatted a little bit better? We absolutely could. If we use our padding commands from our string knowledge, pad right and pad left, and that we could make that perfectly aligned, but we haven't done that yet. Okay, so these are parallel arrays, and these are going to be a really good concept when we get into the gaming side of things for sure. But they are definitely applicable in other things as well. So we're going to finish this off with a couple others that you are definitely going to use. So imagine that you created a function or a procedure. You're creating a method, and you want to use an array in that method. Yes, you can actually pass arrays as parameters. An array is a variable like any other. That means you can pass an array as a parameter to your methods. You can also return an array from your functions. Ooh, that's interesting. However, there's something super important to keep in mind here. Now, we're used to variables, and when we pass a variable as a parameter, what we're really passing is a copy of its value, not the actual variable itself. Arrays are different. Arrays are special. They're not passed by value. They're not passed by a copy. What they are is they're passed by a reference. And what that means is that think of it as when we pass in an array, what we're doing is we're passing in a memory pointer to the original array. So you're actually getting the legit array. That means if you make changes to the array inside of your method, you're actually changing the original array. That could be both good and bad depending on what you're doing. Maybe you're creating a method that sorts an array. Of course you want it to change the array then because you want to change the order of things. But maybe you're doing something else that what you just want to play with the numbers without breaking anything. Well, then that makes it for a less ideal situation. So other than that, what you want to realize is that when you give your parameter array, when you give it a name, It doesn't matter if it's the same as the original array or not, because what that's going to do is it's still going to point to the original array. Maybe I have one array called nums, and then my parameter is called numbers. Numbers is pointing at nums, which is pointing at the data. That's the key here. Numbers is pointing at nums, which is then pointing at the data. So when I make changes to numbers, I'm actually making changes to nums. So that can definitely be a little bit confusing, but that is the way it works. You can return an array that was passed in as a parameter, or a brand new array that you created inside the method itself, and it won't be destroyed as long as you store it. So I'm going to give you a couple examples now that will illustrate this. So first of all, here's an example of arrays passed as a parameter. Now I'm going to draw this out a little bit just so we can see where this goes, and hopefully I don't draw over where my data is going to be displayed here. So imagine, first of all, I create this array called marks, okay? And it's an array of doubles. So I'm going to draw it up here. So I don't know why I'm on red, but whatever. It's fine. So we have 87.4. We have 93. We have 76.8. We have 91.2. Oops, 91.2. And we have 68.5. Now I have another one called speeds. These are not parallel arrays. We can see that one has 5 elements and one that has 3. So this one is marks. Okay. And then we have another one called speeds. And it only has 3 elements. Okay. And this one's 101.2, 105.8, and 98.7. Oops. 98.7. Now, they're not actually stored in RAM like this, though. In RAM, it's more of a vertical structure, but it still operates in the same way. So imagine this is my RAM. Now, my RAM, let me just kind of write this out here. What happens is when I create this marks array, it finds the first available amount of memory that can hold 5, in this case, doubles. So imagine it's taking up the first 5 slots. Oops, didn't mean to press that hard. So imagine it's taking up these slots, and this is called marks. And it fills these slots up. So we have our 87.4, our 93, our 76.8. Our 91.2, and our 68.5. And then right after that, we're creating an array called speeds, which takes up 3 slots. Oh my goodness, writing too hard. Okay, and this one takes up 101.2, 105.8, and 98.7. So this is how it's actually stored in memory right now. So it's taking up this much space right up to that point. So we get over here. I'm also creating 2 variables, one called average mark and one called average speed. So this one may be down here, average mark, and this one down here is average speed. Oh my goodness. Okay, there we go. So we've got all this stuff. Average mark and average speed don't have a value right now. Now watch what happens here. I'm going to say average mark is assigned, that's a function call, to a function called average 3 nums. And look what I'm passing in. I'm passing in marks as a parameter. So what that does is it jumps down to that method called average 3 nums. So we can see that this is a private static double, so it's going to return a double, and it takes an array of double, and we called it nums. So what happens here is it creates another variable called nums. Okay? And since we passed marks in as the parameter right down here, what happened is that this nums is actually pointing here. It's not creating anything new in memory this time. It's just pointing directly in here. So then it goes into the code inside of the method, and it calculates result, which is another spot on memory down here. Okay, result. And it calculates that as nums0, nums1, nums2 divided by 3. Now, it's called average 3 numbers. So what this thing is going to do is it's going to find the average of the first 3 elements of any double array. So it took a double array, added the first 3 elements up, and divided specifically by 3 because it's finding the average of 3 numbers. And then when it's done, it's going to return that result back to wherever it was called. Now, in this case, it's 87.4 plus 93 plus 60 plus 76.8. I don't know what that is off the top of my head. It's 80 something. So it's going to take that 80 something and it's going to send it back up to where it was called. So this entire thing is going to get replaced with that 80 something, right? 87 or whatever it is. And then that is going to get stored into average mark. And now that method is done. So everything inside that was created gets destroyed. In this case, the result variable. So this goes away, result goes away. Now in the next line, I calculate average speed. And this time I passed speeds in here. So nums got destroyed because that was a local temporary variable. So this thing got destroyed. So that pointer's gone now. So now when we pass this in, we create a speeds variable. Or sorry, we create another nums variable again. But this time it's speeds that's pointing at it. So that means nums is pointing at speeds now. Oh, okay. So now it goes through and it adds up the first three elements of speeds. Nums 0, which is really speeds 0. Nums 1, which is really speeds 1. Nums 2, which is really speeds 2. And it adds those up and it's probably going to get a little over 100. And it's going to send that number back. So then we can actually display it. And what we end up with is this. Oh, it was 85.7, not 87. So that actual number got sent back. Now, if you look at the, why is it such a pretty number? Because I actually rounded the data here so we could see it to one decimal place. Otherwise, it would have like 15 decimals or something. So these values were stored of the results. So we passed in a different array each time. Even though it's called nums in here, that doesn't make a difference. It's just a nickname. And that nickname is pointing at whatever array was passed into it when the method was called. Now, again, if I change something in here, if I did something like this, nums at 0 is equal to 5, that would change, in both cases, it would have changed this 87.4 to a 5, and it would have changed this 101.2 to a 5, because they were both passed in. Then it would do the math, and that would break everything, of course. Okay? So that's the first example, arrays as parameters. So remember, it's not a copy, it's the actual array itself. Okay? What if we want to return an array? So this example is a little bit longer, but hopefully it spells things out a little bit better for you. So imagine that we want to create a function that uses a function to ask the user for 3 names. That should be create a program. Create a program that uses a function to ask the user for 3 names to fill an array that is then returned and stored for later. Now, how many times have you created programs so far this semester that you've had to ask the user for multiple pieces of data, and sometimes the same pieces of data multiple times? Well, we know that we can make our lives easier with methods. Great. Now, what if we want to return more than one value, like more than one name we ask the user for? Well, that's where arrays come in. So I've already set up the scanner here. So imagine I create 2 arrays. You'll notice this time I didn't specify their size. String array first names, string array last names. Basically what I told the compiler this time is, hey, I'm going to create a couple of arrays of strings. I don't know how big they are yet though, but please add these 2 names, these 2 identifiers to your dictionary. Okay. So Java says, no problem, I got you. And then the next line we're saying, well, let's assign some data to this. Instead of saying equals new string some other size, this time we're saying equals get 3 strings, enter first name. What the heck is that? Well, get 3 strings is a method that I created for you. And what does it do? Well, it's going to ask the user for 3 names. And then it's going to return it. You'll notice that there's only one parameter, prompt prefix. So I'm asking for this method is, what do you want to ask the user for? In this case, I want to ask the user for first names. So I'm going to create an array inside here to store all the names that I'm asking the user for. Now, this is a temporary variable at the moment. Now, here's me asking for that first name. System.out.print prompt prefix, so enter first name plus 1. So that's going to look like this. That's going to look like enter first name and then space 1 colon space 1 colon. And then that means when the user types, they're going to be typing right there. Okay. So let's say they type in Bob. Okay. That means Bob would then be read in and stored at index 0 of the array. Now I can do that for 2 more names. Great. So now result is holding 3 names. And you can see each time I just said prompt prefix, and then I added on the next number so the user knew what to view it as. So now I'm storing them at index 0, 1, and 2, because those are how our indices are numbered. And then finally, when I'm done, I'm going to return the array. Look how the data type for the return is. Just string square bracket, just like it is if I'm defining an array over here. Now when I say return result, this result variable is currently in memory. And what it's doing is it's going to get first names to point to that same location in memory. So it's actually returning the array. So first names after this point on will have a pointer directly to it. Great. So then we do the exact same thing for last names, and it gets its own set of 3 names. So now your RAM is holding 2 variables, one called first name, one called last names, that are both pointing to their own locations of memory of 3 separate names. And it's the exact same thing, only this time I changed the prompt to be enter last name. And then finally, I want to display this stuff out. So you can see here I'm saying person 1, first name, and space, and last name. So this, I'm using parallel arrays here again as well. And I can do that for the remaining 2. And what we can see here over here is the input. So this is me calling the input, the method the first time. Enter first name 1, Bart. 2, Lisa. 3, Maggie. Enter last name 1, Simpson. Last name 2, Simpson. Last name 3, Simpson. And then when I display them, person 1, Bart Simpson. Lisa Simpson. Maggie Simpson. So we get all 3 of the values here. So what we've done in this lesson is we've really applied arrays in a number of different ways. Now, eventually you're going to want to use these arrays in your video games. You absolutely can. So for example, you could have an array of sprite sheets. Maybe you have an array of animations for a character, and each animation might be like a walking direction for the player. So you keep track of what state they're in. Maybe they're walking up, down, left, or right. And if you use those as constants, 0, 1, 2, 3, 4, maybe those can represent the index values into your array. So you're only ever drawing the animation that you want to. Maybe you're using an array for your inventory, whatever kind of game you're making. Maybe it's a game like Super Mario Brothers, and you have an inventory of items that you've collected. Or maybe you're using it for something else completely. It doesn't really matter. Point is that we're going to be able to apply these things all over the place. You're going to find tons and tons of uses for it. But for now, that's about it. So good luck.